Okay, today we're going to be doing lesson 15 from module 3, which is all about solving multi-step word problems. And so we're going to be adding and subtracting our fractions in a word problem format. Now, today's video is going to be a little bit different in the terms that I will be solving and working with you on the first problem all the way through, like I normally do, where we'll be doing it together, you're working with me, and we'll solve it live together. And then for questions 2 through 5, what I'm going to do is help you set them up, read the problem, draw it out, and get you going. And then I'm going to have you pause, solve it on your own, and then come back and check as the video continues. And the reason I'm doing that is because I want to help set you up for all of the problems, because I really think that the word problem practice is important, but then I also want to make sure that you're getting some practice on your own of actually doing the math. So let's get started with question number 1, which is a baker buys a 5-pound bag of sugar. She uses 1 2/3 pounds to make some muffins and 2 3/4 pounds to make a cake. How much sugar does she have left? So let's identify our important information. She buys a 5-pound bag of sugar. So that sounds like what she starts off with is 5 pounds. So this is her starting. Now, she uses 1 2/3 for muffins and 2 3/4 for a cake. And they want to know how much does she have left. So let's draw out our tape diagram. For every word problem that we do, we're always going to draw our tape diagram so we understand what math we're actually supposed to do. So we know that she starts with 5 pounds. That's the total amount of sugar she has. And then we know she makes muffins. And we know she makes a cake. And then we know she has what's ever left. Let's fill in our information. She uses 1 2/3 pound for muffins, 2 3/4 pounds for cake, and then we do not know what's left. And that's what we're trying to figure out. It's a horrible question mark. Okay. We're trying to figure out what she has left. Now, looking at this problem, I know the total, and I know some of the pieces. So I'm thinking it's going to be a subtraction problem. I think I want to do 5 minus what she used will give me what she has left. But before I can do that, I need to combine my two things that she used. I need to know in total how much did she use. So I need to add the muffins and the cake together to find how much she used in total. So I need to do 5 minus, or not, no, we're not there yet. 1 2/3 plus 2 3/4. That will tell me what she used. So let's do that and set it up with our common denominator. So it's going to be 1 and something plus 2 and something. Looking at 3 4/4, a third and a fourth as my denominators, I know that 3 times 4 is 12. So my new denominator is going to be 12. So 3 times 4 is 12 and 2 times 4 is 8. 4 times 3 is 12 and 3 times 3 is 9. So I get 1 8/12 plus 2 9/12. When I add those together, I'm going to get 3 17/12. Well, 17/12 needs to be simplified. So I can do 17 divided by 12. And I get 1 5/12. So really this is 3 plus 1 5/12, which is 4 5/12. So in total, she used, so this number right here, she used was 4 5/12. So now if I think about my diagram, I've made it a little more simple. I know we have 5. I know this is 4 5/12. And then that is my question mark of what's left. Now it's telling me to do subtraction. So 5 minus 4 5/12 will give me what she has left. So I can rewrite this because I need to do a fraction. So I'm going to rewrite 5 as 4 12/12. And the reason I'm writing 12 twelfths is because my denominator is 12, so I might as well make it easy for me. So 4 and 12 twelfths, because that's the same thing as 5, minus 4 and 5 twelfths. 12 minus 5 is 7 twelfths, and 4 minus 4 is 0. So 7 twelfths is what I have left. So it's 7 twelfths pounds sugar are left. So my final answer then is 7 twelfths. So now let's look at question number 2. And again, I'm going to set this one up for you. So work with me here. A boxer needs to lose 3.5 pounds in a month to be able to compete as a flyweight. In 3 weeks, he lowers his weight from 55.5 kilograms, he needs to lose 3.5 kilograms a month. I was confusing kilograms and pounds. Let's start this over. A boxer needs to lose 3.5 kilograms in a month to be able to compete as a flyweight. In 3 weeks, he lowers his weight from 5.5 kilograms to... He lowers his weight from 55.5 kilograms to 53.8 kilograms. How many kilograms must the boxer lose in the final week to be able to compete as a flyweight? So let's reread this. I know I'm confusing these numbers up, so I need to reread it. A boxer needs to lose 3.5 kilograms. So that's how much he needs to lose in total. In 3 weeks, he lowers his weight from 55.5 kilograms to 53.8. So I can think of this as kind of like before he weighed 55.5 and after he weighed 53.8. How many kilograms must the boxer lose in the final week to be able to compete as a flyweight? Well, I know in total he has to lose 3.5 kilograms, or because we're talking about decimals here, I can say 3.5. He has to lose 3.5 kilograms is what he needs to lose. So I need to figure out how much he has already lost. So what's this amount? And see how does that compare to 3.5? Because we know he's lost some weight. So because this is already in decimals, we can just keep these in decimals. That'll be easier for us. So let's do 55.5 minus 53.8 and see what we get. So it looks like he's already lost 1.7 kilograms. He needs to lose 3.5 kilograms. So if we think about it like this, his goal is 3.5. So far, he's done 1.7, and we need this mystery amount. So we can figure out that mystery amount. Go ahead and pause here and find that mystery amount for me, and then you can check your answer when you're done. Okay, here's my answer. He needs to lose 1.8 kilograms in the final week, and you can see my work that I did for that. Okay, let's look at question 3. A construction company builds a new rail line from town A to town B. They complete 1 1/4 miles in their first week. I cut it off a little bit, but that's a 1. 1 1/4 miles in their first week of work and 1 2/3 miles in their second week of work. If they still have 25 3/4 miles left to build, what is the distance from town A to town B? Okay, so let's think about what we know. We know they're trying to go from town A to town B. We know they've completed 1 1/4 in week number 1. So we'll say 1 1/4. So this is their first week. 1 2/3 in their second week. 1 2/3 in their second week. If they still have 25 3/4 miles left, so this would be 25 3/4 left, what is the distance from town A to town B? So we can call this almost town A, this town B, and they want to know the total distance. So looking at this module, we know that we have 3 pieces here. We have the first week, we have the second week, and we have what's left that all together combine to give me the total distance. So this looks like an addition problem where I'm going to want to do 1 1/4 plus 1 2/3 plus 25 3/4, and that will give me my final answer. Go ahead and pause the video right now, finish solving this problem, and then play to check your work. Okay, my work that I did was in blue, and I got the final answer of 28 2/3 miles. Okay, question number 4. A catering company needs 8.75 pounds of shrimp for a small party. They buy 3 2/3 pounds of jumbo shrimp, 2 5/8 pounds of medium-sized shrimp, and some mini shrimp. How many pounds of mini shrimp do they buy? Okay, so we know they need 8.75 pounds. They have, so that's total. This is the total amount of shrimp that they need. They have 3 2/3 jumbo, 2 5/8 medium, and whatever the mini shrimp is. And we're trying to figure out the mini shrimp. So let's draw out our model. We know in total it's 8.75. And then there's jumbo, medium, and mini. Jumbo is 3 2/3. Medium is 2 5/8. And mini is our question mark. So we need to figure out how to find the mini shrimp. This tape diagram reminds me of one that we've already done, but what's tricky here is I've got a mixture of decimals and fractions, and I can't live that life. I need them to be the same. And because I have 2 different fractions, I think it's going to be easiest for me to switch from my decimal to a fraction. And when I think of 8.75, I can read that as 8 75 hundredths. 8 75 hundredths can also be written like that. So I can rewrite 8.75 as 8 75 over 100, and then I can simplify that, divide them both by 25, and you get 8 3/4. So I'm going to rewrite 8.75 as 8 3/4. And that's all in pounds. So when I'm thinking about solving for this, I need to figure out the mini shrimp. And what I would do is combine the jumbo and the medium shrimp to figure out how much shrimp they already have. And then from there, I would take the total shrimp and subtract what they have to find out what the mini is going to be. Pause, do the math, and check yourself. Okay, here's my answer. I got 2 11/24 pounds of shrimp is that he's going to need from his mini shrimp. When I added my jumbo and medium together, I got 6 7/24. And then I subtracted 6 7/24 from 8 3/4, finding the common denominator of 24 to get 2 11/24. If you have a bigger denominator, just make sure that you had simplified it, and you should still end up with the same 11/24. Last problem. Mark breaks up a 9-hour drive into 3 segments. He drives 2.5 hours before stopping for lunch. After driving some more, he stops for gas. If the second segment of his drive was 1 2/3 hours longer than his first, how long did he drive after stopping for gas? Okay, so let's think this through. It's a 9-hour drive. Oops, it's black. 9-hour drive, and it's in 3 segments. So his first segment, it says he drives 2.5 hours before stopping for lunch. That's segment number 1. So I'm going to do a tape diagram here that represents segment number 1, and we know it's 2.5 hours. After driving some more, he stops for gas. So we'll call that segment number 2. If the second segment of his drive was 1 2/3 hour longer than the first, so we know that it's the second segment is longer. So we know it's this amount plus 1 2/3, because it's 1 2/3 hours longer than the first. We want to know how long did he drive after stopping for gas. So remember, he stops for gas right here after segment number 2. So they're basically asking us, what is segment number 3? Because he first drives before lunch, then he drives some more, then he stops for gas. So this is gas. Then he keeps driving, and they want to know how long did he drive after stopping for gas. So we want to find out that mystery question mark. Now, we know in total, this whole thing adds up to 9 hours. Because they said he breaks up a 9-hour drive into 3 segments. And it's all of them adds into 9 hours. So this looks kind of funky, so I'm going to go like that. Now, I've got a lot of pieces here. I've got multiple individual segments that I need to solve for. So what I need to solve for, I need to fill these in. I know that segment number 1 is 2.5. I know that segment number 2 is 1 2/3 plus 2.5, because he drove this 1 2/3 longer than 2.5. So I know that all of those together. And then I know that whatever missing number 3 is, when I add up all 4 of those pieces, I'm going to get 9 hours. So it's going to be 2.5 plus 2.5 plus 1 2/3 plus something is going to equal 9. I don't know that something yet, and I need to figure that out. Let's simplify this problem and combine these numbers as much as possible so I can do that. 2.5 plus 2.5, because they're the same denominator, you can do it, and then you can add the 1 2/3, and then you can figure it out. Solve this math, see what you get for your missing number for number 3, and then come back and check. Okay, here's my final answer. I got that Mark drove 2 1/3 hours after stopping for gas. I did that by adding 2.5 plus 2.5 to equal 5. And then 5 plus 2/3 equals 6 2/3. So I knew 6 2/3 plus something would give me 9. And to help me with that, I was able to switch it around and do 9 minus 6 2/3 would give me something. And when I did that math, I got 2 1/3. So I have Mark drove 2 1/3 hours after stopping for gas. Hopefully you're able to do a little bit of fraction practice today in addition to looking at how we can set up these word problems. Word problems can be challenging, but if we look at them in bits and pieces, identify the important information, and set up models, it helps us know what to do. So then all we have left after that is to do the actual numerical work.